this short video, you'll learn why it's absolutely critical that you do resistance and walking body voltage tests before selecting an ESD floor.
Not doing so can lead to major damage to electronics, to your business, and in some situations can be life-threatening. When we walk, our feet touch the floor, lift, and touch the floor again.
The friction that occurs from this contact and separation moves electrons from one surface to the other, causing an electrical imbalance. This electrical charge stays in place, static, until it's either discharged to ground, through an ESD floor, for example, or moves to another object.
Humans can't even feel a static charge less than 3,500 volts, but a discharge of only 25 volts can corrupt or erase data and damage or destroy sensitive electronic components. To be sure that your floor is going to protect your data, wired networks, and sensitive electronics, we must conduct two separate, equally important tests. One, electrical resistance, to be sure the floor will provide a safe and effective pathway to ground. And two, walking body voltage, to predict how much static will accumulate on the human body when a person walks across the floor. Today, we are going to show you how to perform the electrical resistance test.
To control static, ESD floors are loaded with conductive additives, such as carbon. When people walk across a room, or take off their sweater, or do anything that causes friction, they generate static. The conductive additives in an ESD floor allow static to flow from its surface through the thickness of the floor, providing a safe and effective pathway to ground.
Electrical resistance, the opposite of conductivity, is the property that stops or resists the flow of electricity. Resistance tests use an ohm meter to measure a floor's conductivity. This test will tell you how quickly or slowly the floor will discharge static electricity to ground. If the floor is too conductive, currents will flow too quickly, posing a safety hazard. If the conductivity is too low, static will discharge too slowly, rendering the floor ineffective.
The goal is to find the sweet spot for conductivity, between 1 times 10 to the 5th and 1 times 10 to the 8th ohms, the range that provides the safest, most effective path to ground.
The test that we do, we connect with these leads, each probe to an ohm meter. And we're supposed to separate the probes by a distance of approximately 36 inches. So what we're measuring is the resistance from one tile to the other. And the number we're getting is 8.9 times 10 to the 5th. If you recall, when we were talking about the sweet spot went from 1 times 10 to the 5th to 1 times 10 to the 8th. So the resistance measurements I'm getting right now, we would say they're in the sweet spot. The second test we do is, instead of measuring from one probe to the other across the surface, we connect one of the probes or the lead itself to electrical ground. In this particular case, I've got the electrical ground set up to be a copper strip. And we do that test. We get 2.2 times 10 to the 5th, or well, it's now 2.1, or 210,000 ohms. Once again, it's in the sweet spot. In our next video, we're going to show you how to conduct a walking body voltage test, the other thing you need to do to make sure that your facility is safe.
For more information about this test, or to view ESD flooring options, visit StaticWorx.com, your trusted ESD flooring partner.